So as you can see in the title, I'm going to be talking about examples of sites. The first example is the small Zariski site. There's a little bit of an echo. 1 second. Let me get close to it real quick. Okay. So we have this small Zariski site here, so this was the prototype that we devised for a site, and what we do is we fix a scheme X and we consider this site, this growth and G-topology, which we'll call XZAR. And this is going to be a pair, so we have a category, and then we have a growth and G-topology here. Here, this is, so let me say this, this is the small Zariski site. Of X. Here, the category is this what we called open X, and this was open immersions plus inclusions. And then, so those are the morphisms, and then the growth and G-topology was if we fix, so we for U an open, we define the Zariski covers to be covers of U by open immersions. Okay, and so this will actually define a growth and G-topology, so we need to check the axioms. Okay, let me do the next example. So this is going to be the big Zariski site. Okay, and I'm going to give a little warning here. There's some set theoretical issues, and I should say a big Zariski site, because you kind of need to fix a cardinality and then to make things work out set theoretically. So there is some set theory to deal with. And I'm going to omit this, and I'm just going to refer to it as a single big Zariski site. But this is much like going to like large fields, large algebraically closed fields, or in model theory they call these saturated models. Anyway, so now what we're going to do is we're going to say what we're going to do is we're going to do for the entire category. Of schemes. Okay, so here we fixed a scheme, and now we're looking at the entire category. What we're going to do is we're going to look at this thing where we have the category of schemes and the covers by open immersions. So the category in this case is just the entire category of schemes, all the maps. And then the growth and G-topology. Okay, well, we have to say for Y a scheme, the Zariski covers of Y are going to be covers of Y by open immersions. Okay. Okay, so this is this one, and then the last version is that there's kind of a relative version. So the big Zariski site of, let's say, a fixed scheme. So here we're going to fix X, a scheme, and we're going to look at the category of schemes over X, and we're going to look at this Zariski topology again. So the category here, so this is just going to be schemes over X. So again, this is the objects of this, the morphisms. So the objects are maps like this kind of over category, and the morphisms are dudes like this. So a morphism between these two guys is one of these. And then we need to talk about the growth of G-topology. Okay, so we need to say what happens when we take a scheme over X. And what happens is that we just do the exact same thing. So this is going to be covers of Y by open immersions. Again, like I said here, there's the same warning applies. Whenever you're doing a big site, there's kind of some set theory where you need to fix a large cardinal. Okay, so I didn't really verify that these are sites. So let's ask, why are these sites? Well, let's recall the axioms. There's 3 axioms of a site. There's you have trivial covers. You need to be closed under base change, and you need to be closed under composition. Okay, and so if you take an open immersion, well, if you take a morphism of schemes, it's an open immersion. The identity is going to be an open immersion, so we get this one. Okay, if you take an open subscheme of a scheme and you intersect, then you're going to you intersect a cover with the open subscheme. You're going to cover that open subscheme, and this is what the base change thing says. Okay, and then the last thing says that is that if I have an open cover and I cover each of the open covers themselves, then the collection of covers all together of all of these things will constitute a cover of the main scheme, and that's what gives us this thing. So that's how we check the axioms for the Zariski coverings. I'm going to stop here, and then in the next video, I am going to talk about the generalization of these small sites, the small, big, and relative sites for in general. Okay, so I'm going to stop.